Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a brief overview on the different types of graph transformations. In the next video, we'll be then going through actual questions and seeing how we apply them. So, the overview is there are three types of graph transformations. The main two are the first ones you can see here, reflections and translations. Then we do technically have a third one which is called enlargements, but this tends to be mostly just for trigonometric graphs, so that's kind of a little bit separate. So obviously they're kind of in the name. Reflections means we're going to be reflecting the graph either in the x-axis, so up and down, or in the y-axis, so left and right. Translations means we're moving it. Okay, so we might be moving the physical graph a few squares to the left or to the right, or a few squares up or down. And then enlargements means we're stretching the graph. So even though it says enlargements, that doesn't necessarily mean it's getting bigger all the time. It could actually be getting smaller. So it can either get taller or shorter, or it can get kind of like wider or narrower, okay? Now, beyond that, we do actually need to memorize how we are given these types of, instructions in a way, if you want to think about it like that, because they're unlikely to just say, oh, reflect this graph in the x-axis, for example. They're going to give you some format of y equals f of x. So here, the darker blue curve is the original, okay? So that one's normally, they'll say, oh, here is a graph of y equals f of x. Now f of x just means a function. In this case, obviously you can see it's a quadratic. It could be any shaped graph, it doesn't really matter. And then they'll say on the graph, sketch y equals, for example, minus f of x. So you have to know what instruction is that. So it's not necessarily hard if you've got the flashcards in front of you. The hard bit is having to memorize it for the exam and not get them mixed up. So looking at reflections, for each of our transformations, we've got two versions, obviously one for the x-axis, one for the y-axis. So for reflections, we've got y equals minus f of x or y equals f of minus x. So reflections, you're looking for a negative. We've not got any numbers. I think that makes it obvious because you can't move it up and down, left or right. It can't be a translation without numbers, for example. It can't be an enlargement without numbers because you wouldn't know how far to stretch it. So if it's only got a negative and no numbers, you know, okay, that's obviously just a reflection. But then you go, right, okay, so it's a reflection, but what type am I reflecting? Am I putting my mirror on the x-axis or on the y-axis? And this is where it gets a bit complicated because, for example, this one here where you've got minus x, you think, oh yeah, that'll be a reflection in the x-axis because it's next to the x. It's not actually, it's a reflection in the y-axis. So this vertical line here. Now, the reason why the negative is next to the x, it's not a reflection in the x-axis. However, do you see how, if we look at the original being the darker blue and then the reflection being the lighter blue, what has been affected? The x coordinates have been affected. For example, this was 3, now it's minus 3. However, you can kind of see on the y-axis, those ones haven't changed, have they? Okay, it's still at this point here, it's still at this point here, just a different x value. So you're going to remember it however you find it easier to remember. I remember when I was in school, I just in my head went, it's the wrong way around to what you would naturally think it should be. Because naturally you think, oh, reflection in the x-axis because it's next to the x. And I go, no, wrong way around. Reflection in the y-axis. Or, as I've written here, you can think of it as it's affecting the x coordinates, therefore it's a reflection in the y-axis. Okay, it doesn't matter how you remember it, just make sure you remember it correctly. And if you look at this one here, the first one, the negative is closer to the y, isn't it? And you go, okay, well maybe that's affecting the y-axis. Well, it's actually not the y-axis. It's a reflection in the x-axis. It's affecting, though, the y coordinates. Because as you can see, obviously 0 will stay the same because that's on the line of reflection. But let's say this point here and this point here, it was at 4 on the y-axis. Now, and if I've obviously drawn a rough sketch, it's on technically minus 4, isn't it? But the x coordinates have stayed the same. Okay, so however you want to memorize it, that's up to you. Just remember, one is a reflection in the x-axis, therefore the y coordinates are affected. One is a reflection in the y-axis, therefore the x coordinates are affected. Okay, so that's reflections. Translations. This is the one where it means we're moving either up or down or left and right. This one's a bit more straightforward. So you're looking for, if we got, I've used A obviously as a letter, but this would be a number. Either plus or minus a number, right? So then we've got to go, okay, well, it's a translation because we're adding or subtracting a number. But then I have to figure out translation where? Is it on the y-axis going up and down? Or is it on the x-axis going left and right? And that's where you see, this one does feel like it's the right way round in terms of the fact that if it's next to the x, it's affecting the x-axis, it's affecting the x-coordinates, and if it's on the outside, it's affecting the y-coordinates, the y-axis. Now, the y-axis ones tend to be kind of normal, and what I mean by that is if it says plus, move it up. So for example, if it says plus 3, move it up 3. If it says minus, move it down. So that's pretty straightforward. But there's always something, remember this transformations, there's always something that's not quite as you'd imagine it should be. So normally it's to do with the x. This one, we have said, okay, yeah, if it's next, plus or minus next to the x, it is left or right. However, if you have a look at my little arrow here, you'll see that it's kind of the wrong way around to what you'd think. If it says plus, so for example, if it says plus 3, I actually need to move it 3 to the left, so I'm kind of actually subtracting 3. And if it says minus, I need to move it to the right, so I'm kind of actually adding. So for example here, if obviously the dark blue being the original graph, you can see originally, let's go with this point here, it was on 0. It's now moved to, let's say that was exactly on 4. It's technically plus 4, isn't it? You've added 4, but in terms of how it would be written, it would be y equals f of x minus 4. And you just have to remember, okay, it says minus 4, but that means I need to add 4. So there's always something that's the wrong way round. So that's translations, okay, up and down, left and right. And finally, I have done it with a quadratic graph, but as I said, this is mostly for trigonometric graphs, so it's not really, can't really see it very well here. We've got enlargements. Now, again, this one is the right way round in terms of the fact that if it's next to the x, it affects the x coordinates. If it's not next to the x, if it's closer to the y, it affects the y coordinates. Now, this one also has a number. Again, a does represent a number, but you can see how it's actually multiplied now. That's kind of like a times f of x, isn't it? Or this one is like f of x times a, isn't it? It's not plus or minus like the translations. So I think that's quite obvious as an enlargement that we're timesing it by a scale factor. Now, if it's on the outside of these brackets, if it's closer to the y, it's affecting the y coordinates. So all you need to do is take each of your y coordinates that are pretty obvious coordinates and multiply them by the number that's in front. Okay, if it was a half, it would get kind of shorter, which is why it's harder to show on quadratic graphs, because they go up to infinity, don't they? Obviously, trigonometric graphs, for example, the sine or cosine graphs are like this, aren't they? They've got limits vertically. So you can tell whether it's gone shorter or if it's gone taller. Okay, so just for this one, you are going to take your y coordinates and multiply them just by that number. So it could get taller, it could get shorter, it just depends what the number is. Now this one over here, the number is next to the x, so yes, you're going to take your x coordinates and multiply it by this number. However, there's, again, always something that's not as it should be. So here, can you see, we're not just going to multiply it by a, we're going to multiply it by 1 over a, or effectively the reciprocal. So, for example, if it was y equals f of 2x, I'm not going to times my coordinates by 2, my x coordinates, I'm going to times them by half. So that would actually get narrower. Okay, this one here, you can see the lighter blue has got wider. So let's say if it was y equals f of 1/3 x, don't go, oh, it's already 1 over a number, so that's how it is. No, you need to do the reciprocal of that. Now, reversing the reciprocal, that just becomes 3 again, doesn't it? So in that case, it would get 3 times as wide. Okay, so the enlargement transformations we're mostly going to be looking at in the 3rd video in this series, which is when we look at transformations of trigonometric graphs. The next video will focus on the first 2 that we looked at, reflections and translations mostly, okay? So feel free to go back, screenshot these pages if you want to use them as like flashcards. You just have to memorize these little, I guess they're called like instructions, aren't they really? It tells you what to do. You have to memorize what each of them means. So as a quick recap, we've got 3 types of transformations. Kind of draw a separate little line there. The main 2 are reflections and translations, so in the name, reflecting it like a mirror, or moving it up and down, left or right. And then the last one is enlargements, which you're more likely to see with trigonometric graphs. So not as common, that one, okay? So thanks for watching this video. Hopefully you found it helpful. Definitely check out the next video, which I'll link here now, because that's when we will be going into actually applying these transformations to questions, so you can actually see and get a good idea of what we're actually talking about and how it all works. As I said, you do need to memorize these types of transformations so that then you can just regurgitate it in your exam. So thanks for watching this video. Hopefully you found it helpful. Leave down below any questions you might have and make sure to subscribe.